Alrighty, welcome guys to our very first review video for Algebra 2. Test coming up either Thursday, Friday, or Monday, depending on which class you're in. And we're going to go over every single one of these questions nice and slow. If you already know how to do it, feel free to fast forward. If you don't know how to do it, you can obviously watch, and if I talk too fast, you can rewind and maybe listen again. Give me some advice if I need to do something different. Just tell me in class, leave a comment, whatever it is. So let's get going. So honestly, there's only two types of questions on our first test because we've only really learned two things. We learned factoring, and we learned how to graph quadratics in factored form. So, I actually put all the review problems for graphing in factored form already. They're already nice and factored for you. On the actual test, they will not be factored. You will have to factor them. But I wanted to be nice for the review so you don't have too much work to do. So let's get going. Solve each equation by factoring. So to solve these equations, we need to move everything to one side of the equation. We want to choose the side that is going to make the squared term positive. So in this question, we're going to go ahead and add x squared to both sides. And we're going to add 2 to both sides. And we need to make sure we just add like terms correctly. So when we add like terms correctly, the x squared is going to go first. 6x doesn't have anything added to it. And 3 plus 2 is 5. After that, don't forget it still equals 0 in the end. After this, we have to do our basic factoring process. The process for factoring is the same every time. We need to multiply to this. Multiply to the constant, or the last term if you don't want to say constant. And we need to add to the linear. Or you can think about it as the x if you'd rather. So you need to think of all the numbers that multiply to 5. For this question, it's very, very easy. Only one set of numbers multiplies to 5. 1 times 5. Or one set of integers, rather. Once you've written down the ones that add to 5, multiply to 5, you're going to see if they add to 6. And in this case, they do. So those are your answers. X plus 1, x plus 5 equals 0. However, those are only your answers to the factoring question. The answer to the actual question is you have to set these equal to 0 separately. And subtract 1 on both sides and get x equals -1. There's my first answer. And here, x equals -5. Let's move on to number 2. So number 2, same idea. This 5m squared is already positive, so all we got to do is subtract the 8m over. So please note where did I get that 5m from. I subtracted 8m on both sides. I'm just not showing my work because I'm going to run out of room, I think, if I do that. Now we're going to notice that we have a 5 that is divisible in all three terms. So we're going to divide by 5, divide by 5, divide by 5. If we divide by 5, divide by 5, divide by 5, we can pull out a 5 out in front of the entire question. So 5 divided by 5 is 1. Don't have to write the 1 if you don't want to. I recommend not doing it. 5 divided by 5 is, again, 1. I recommend not writing it. And it turns out that 210 divided by 5 is 42. Feel free to use your calculator if you need it. After that, same exact steps as this question over here. We're going to figure out what multiplies to -42. So multiplies to -42 is what we're asking. Well, obviously one of them needs to be negative, but let's just figure out what multiplies to it first. We know that 1 times 42 works. 2 times 21. And now, honestly, maybe you can't divide by 3, 42 divided by 3 in your head. And that's okay. So if we want to see if it's going to work, we simply go to our calculator. Some work from the algebra test is on there. And we simply do 42, and we divide it by 3. And it turns out if we do this, we will get 3 there, 14 there, which means 3 times 14 works out. You can do this for all the numbers. I'm not going to, but you are able to for what you want. Turns out if you divide by 4, it doesn't work. Divide by 5 doesn't work. But divide by 6 does. And when you divide by 6, you get 7. All right. So if you divide by 6 and get 7, then we get 6 times 7. Now, we figured out all the things that multiply to 42. So we're done thinking about that. But we do know it must be one of them must be negative. Which one? Because that's a negative, and this is where it adds to the x value, if two numbers add to a negative number, and one is positive, one is negative. So we're having one positive number, for instance, maybe we have like a positive 7, and then we're going to add it to another number, and it's going to end up being negative. If that's the case, it would have to be like negative 8 or bigger, right? Or negative 7.5. Because that would give us like negative 1. If we have a positive number and a negative number, the negative must be bigger. So we know the negative goes on the bigger one in this problem. Now we simply figure out which one of these adds to negative 1. In this case, we have negative 42 and 1. That's negative 41. That doesn't work. Negative 21, 2. Negative 19. Negative 14, 3. Negative 11. But negative 7 and 6, that works out perfect. 5 multiplied by m minus 7 multiplied by m plus 6 equals 0. And by the same logic as over here, when you simply add, subtract to both sides, our final answer is m equals 7 and m equals negative 6. Not too bad. Continuing on to number 3, we're going to do this one faster. I don't think we need to spend nearly as much time on this one because we spent so much time on 1 and 2. So we're going to add 1 to both sides. And I'm confident I can figure out what multiplies to 18 and adds to 9. I'm not even going to write anything down. So 1 times 18, that doesn't add to 9. 2 times 9, that doesn't add to 9. 3 times 6, 3 plus 6, that adds to 9. Easy. Don't even need to write that down if we can do it. And we can even finalize our answer writing it as x equals negative 3 or negative 6. Don't need to take too much time doing it if we can do it fast. This one I think we need to take a little bit more time to do though. So we have 5n squared plus 2n squared is going to be 3n squared. And then move the 23n over. And then plus 14 equals 0. So I didn't leave nearly enough room for this question. I apologize for that. I'm going to kind of use this section for it. I'm kind of just stealing the problem. So I'm going to rewrite this right here so we have room to do this question. I'm sorry about that, guys. Maybe you need to write this on a separate sheet of paper. But this type of problem has a different process because there is a number in front. This number in front, that messes stuff up. This means we got to factor by grouping when there's a number in front like that. To factor by grouping, our first step is to take the guy in front and the guy on the end. So that's our x squared term and multiplied by the constant term. So step 1 is the squared term and squared multiplied by the constant. And in this case, that is 3 times 14, and that's going to give us 42 again. Luckily for us, we wrote up here all the ones that multiply to 42, so we can actually just write those again if we want to. A lot less thinking that way. Okay. However, this time, it multiplies to a positive. It multiplies to this positive 42, but it adds to negative 23. If it multiplies to a positive and adds to a negative, only way that can happen is if you have both of them being a negative sign. And now we just need to figure out which one of those adds to negative 23. Well, negative 2, negative 21 work out perfect. So this is that weird step. We're going to take that negative 23, and we're going to split it up into negative 2 and negative 21. Let's watch that happen. 3n squared, and instead of writing negative 23, we're going to write negative 2n, this guy right here, and again, minus 21n, plus 14 still, equals 0. So we have split that up. Now that we've done it, we need to draw a line down the middle because we're splitting this up into two separate questions. So just like in our very first problem, or second problem up here where we took out a 5 and divided them all by 5, we need to do the same big idea down here. Except this time, they share an n, so we're going to factor out an n. Over here, they share a 7. In addition, that guy is negative. If this one's negative, you always have to pull it out every time. So negative 7, that's 3n, and if you pull out a negative from a positive, it becomes a negative. I'm running out of room to write equals 0, but it still equals 0. Finally, if these two things are the same, you've done the right step. So because those are the same, we've done it right. Up to here, we know we haven't made a mistake yet, and we can rewrite it. We're going to pull that 3n minus 2 out. So we've taken away this 3n minus 2. We've taken away this 3n minus 2. What's left over? N minus 7. And this still equals 0. And now it's just like all those other questions. We set 3n minus 2 equal to 0. This one probably is obviously n equals 7. But 3n equals 2. We added 2 to both sides. Divide both sides by 3. N equals 2/3. Both of our answers. So I'm just going to walk us through it one more time just so we can hear it again. Step 1, we noticed there is a 3 in front instead of a 1 in front like these other questions. And because there is a 3 in front, we have to factor by grouping. First step is to multiply the n's. We get this positive 42. The next step is similar to all the other questions. We write down all the numbers that multiply to 42, and we're figuring out which ones multiply to that positive 42 and add to negative 23. Because it was a positive 42 and a negative 23, we knew they both must be negative. Turns out negative 2 and negative 21 work. We took that negative 2 and negative 21 and used them to rewrite negative 23 as negative 2 and negative 21. Then we pulled out an n from n squared and n, pulled it out. We have a 7 to pull out from these two. After we pulled out the n from here and the negative 7 from here, we took the 3n squared, pulled it out, because it was the same on both. What was left over was n minus 7. Finally, we use our zero product property, set 3n minus 2 equal to 0, n minus 7 equal to 0, n equals 7, n equals negative or positive 2/3. Let's continue on to number 5. So again, we gotta keep going. Add 6n to both sides, 6n squared, sorry, add n to both sides. That's gonna give us a total of 5n squared minus 43n plus 56 equals 0. Now it's the same as this question over here, basically. We got to be doing all this work. So first things first, 5 times 56. And that's going to give us a rather large number of 280. And now we got to figure out all the things that multiply to 280. But we're going to go ahead and do it slightly differently this time, because instead of writing them all down and then thinking about it afterwards, we're just going to start writing them, and then we're going to stop once we get to the right answer, because it's going to make our life a little bit easier. So we know it multiplies to a positive, but adds to a negative, so it multiplies to a positive, adds to a negative. So they both must be negative. So negative 1 times negative 280, that doesn't work. Negative 2 times negative 140, that doesn't work. Negative 3 actually doesn't divide into that. Negative 4 multiplied by negative 70, that doesn't work. Negative 8 multiplied by negative 35, and again, you could use your calculator, but this does work. Negative 8 minus 35 is negative 43. So we can go ahead and rewrite 5n squared minus 8n minus 35n plus 56 equals 0. Some students have been asking me, does it matter if I write this negative 8n first or this negative 35n first? It totally doesn't. You can write it in any order that you wish. You'll get the same answer either way. So after that, we divide down the middle. What comes out of 5n squared and 8n? Well, only an n. 5n minus 8 left over. Then what comes out of 35 and 56? Turns out it's a 7. And again, if that's a negative, you always got to pull it out. Negative 7. 5n minus 8 equals 0. Sure enough, these two things are the same. 5n minus 8 multiplied by n minus 7 equals 0. And let's do the trick that I was talking about in class. The trick is, if you have anything of this form, you simply write that number over that number in the opposite sign. So instead of negative, it's positive. Easy. Don't have to do so much work. And this one again is n equals 7. It's just the opposite sign, period. All right, number 16. So number 16 has been causing lots of issues for lots of people, mainly because of the I answers. So I have chosen on the test itself not to include the I answers. So you only need to have the real answers. So we still need to do the question, but we need to only get to the real answers. So we don't need to have any I's on the test. To do a question like this, we have to remember the difference of two squares. The difference of two squares says, if I have, and I'm going to write it up here on the paper, if I have a squared minus b squared of any kind, so in this problem I have 16, which is a perfect square, it's 4 squared, minus another perfect square, in this case a 1, which is 1 squared, I'm going to factor into a minus b times a plus b every single time. So the square root of 16 is 4. Square root of x to the 4th is x squared. And then minus the square root of 1 is 1. Square root of 16 again is 4. And we're just going to copy this again with a plus sign equals 0. So this guy right here is going to give us I answers. So we can actually just kind of ignore it for the rest of the question because it's giving us I answers, so I'm not going to worry about it. But this guy right here is the difference of two squares again. You got to notice that we can go ahead and rewrite this as 2x minus 1 times 2x plus 1 because 4 has a perfect square, square rooted, x square rooted, 1 square rooted, same idea. And again, this 4x squared plus 1, not factorable over the real numbers, only the complex, those I answers, and we're going to forget about those. 2x minus 1 equals 0, 2x plus 1 equals 0, and 2x equals 1, x equals 1/2, and if you do this one, you'll get negative 1/2. Not too big a deal. All right, number 7. So number 7 is really the same as a lot of the previous questions, but you have a cube, and that kind of throws people off sometimes, but it's actually not that bad. Whenever you have one of these cubes, all you gotta do is take an x out of all 3 terms first. So I had x cubed, so I had 3 x's, so I took 1 away, now I only have 2. I had 2 x's, I took 1 away, so now I only have 1. I had 1 x and I took it away, so now I have no x's. And now it's the same as all of these questions we've been doing forever. What multiplies a negative 12 adds to positive 1? Turns out that's positive 4 and negative 3. But here's the deal. Students forget, and they get the answer of negative 4, and they get the answer of positive 3 from here, but they forget this guy in front. That guy in front means that x can equal 0 as well. You have 3 different answers. X equals 0, x plus 4 equals 0, x minus 3 equals 0. 3 different things equal 0. X to the 3rd has 3 answers. X to the 4th, that had 4 answers. It had 2 I answers that we ignored. Question 8. Same thing. Factor out an x. X squared minus 7x plus 12 equals 0. Oh man, this was funny. This one has the same numbers, 4 and 3. Too crazy. Minus 4 minus 3 equals 0. X equals 0, 4, or 3. Easy enough. We are done with this first page. Let's move on to the graphing. So here we go. Sometimes these graphs are a little bit annoying. And the main reason they're annoying is that the graphs don't always fit perfectly on the page somehow. And that's okay. We just have to graph the best that we can with the numbers that we're given. And we're going to have to note kind of to ourselves where they're going to end up. So this question, we have 2 multiplied by x plus 6 times x plus 3. Step 1 that I told you to do in class every single time. We're going to go ahead and we're going to find the y-intercept. The y-intercept is where the graph crosses the y-axis. Now, where does it cross the y-axis? In this problem is actually not going to show up on the page, but that's okay. It's not going to show up. We don't need to graph it if it doesn't show up, but we still need to find it and note where it would be. It's an important process in a lot of different questions. So finding the y-intercept is going to be when x equals 0 every single time. So we plug in x equals 0. F of 0 equals 2 multiplied by 0 plus 6 times 0 plus 3. And that's 2 times 6 multiplied by 3. And that's going to give you 2 times 6 plus 3. That's 12 times 3 is 36. So that means we have the coordinate 0, 36 as our y-intercept. Unfortunately, we can't graph that, so we're not going to have to graph it, but we know that that's one of our coordinates. Let's do step 2. Please note on the test I made sure that everything shows up, but sometimes on these review packets they don't always show up. Step 2 is to find the x-intercepts. When I say x-intercepts, it's possible to have 0, 1, or 2 intercepts. On our test right now, we're only going to have 1 or 2. We're not going to do with the 0 ones for a while, but we're going to go ahead and find those x-intercepts. This means that y equals 0, which means the same thing as f of x equals 0. So we're just going to take the original function up here and set it equal to 0. I told you I was nice. I already factored these for you. Because I factored them for you, it's nice and easy to write. X equals -6, x equals -3. This gives us 2 coordinates. Remember, we're making y equal to 0. The y coordinate is equal to 0. And the x is -6. And the x is -3. If you want to, you can actually just put them on the graph right away. Alright, so we got -3 right there. And we got -6 right there. Okay, cool. We couldn't put that 0, 36 on the graph. It was too high up. But step 3. Now, we're going to use the x-intercepts to find the vertex and axis of symmetry. So I'm going to write AOS for axis of symmetry. If you need the whole word written out, it's up there for you, axis of symmetry. Okay, find the axis of symmetry and the vertex. To find the axis of symmetry, there are 2 ways to do it. Way number 1 is to use a formula. Take the 2 answers from before. In this case, -6 and -3. We're going to add those together. And once we've added them together, we're going to divide by 2. So -6 plus -3, that's going to give us -9. And then divide it by 2. And that's going to give us -4.5. Or you could leave it as -9 over 2 as you want. So that means -4.5 is our axis of symmetry. Another way of finding our axis of symmetry is to go ahead and draw -6 and -3 on a number line. And we simply have to meet in the middle. So we're going to go 1 to the left, or 1 to the right there, and then 1 to the left. And now it has to meet smack dab in between -5 and 4. Right there in the center. What's between -5 and -4 is -4.5. So that's another way to do it. Either way, we have found our axis of symmetry, which means that -4.5, which is right here, we can draw a vertical line going straight up and down. But to actually find where our vertex is, we're going to need to plug -4.5 into our function. So we need to do f of -4.5, which is 2 times -4.5. Oop, no, plus 6. Oh man, that was terrible. And then -4.5 plus 3. If you do all this work, it ends up being -4.5 again. I recommend plugging into our calculator for us. That will not happen usually. It just so happened on this question, if you plug it all in, you get -4.5. Which means you have the coordinate -4.5, comma -4.5. So now, let's go ahead and graph it. So -4.5, -4.5, that's going to be right here. We have at least 3 of our coordinates, so we can graph. But maybe we want some more coordinates, and maybe we didn't want to plug this in at the bottom down here too much, and we want to be absolutely certain that we've done everything right before we put everything down on the page, because we're writing in pen, and that's what happens sometimes. So what we're going to do is we're going to go ahead and go over how to do this on the calculator one more time. So to do this on the calculator, clear off your y equals screen. Hold on, I went too fast already. Hit the y equals button, top left-hand corner. After you've hit the y equals button, we're going to go ahead and type in the original function. We don't need the f of x, that means y. So we just need this part up here. So 2 parentheses x plus 6, end the parentheses, new parentheses, x plus 3, end the parentheses. Go ahead and hit graph. Once you've hit graph, we can go ahead and verify a couple of our coordinates. We can verify coordinates by hitting trace. And if you notice, it starts off saying 0 and 36. And that's good. We got the y-intercept right. Then we can type in -6 if we want to, using the small negative sign. We type in -6, we get 0. Nice, that's exactly what we wanted. And if we type in -3, we also get 0. Great, so we did that one right as well. And then we said -4.5 is our axis of symmetry, our vertex. So if we type in -4.5, it turns out, yes, it is -4.5 at the bottom there as well. But let's get some more coordinates on our graph. Maybe get a couple more so we can actually put these on. So try one right next door to what we've already gotten. So maybe we should plug in exactly -4 and see what we get. So -4 gives you -4. And it turns out then that -5 is going to give us, oh, you can't see it, -4. I think I moved my camera when I hit my elbow. My bad, guys. Let's see if I can rearrange. Okay. Anyways, so you get that -4. We can also plug, so we got 5 coordinates now, but let's make it perfect. You want an absolutely beautiful 100%. Plug in, how about -2 as well? So -2 gives us 8 all the way up here. And that means if we went over half and then 1, 2 more, so half and then 1, 2 more, it's going to work as well. We can double check, plug in -7. Do we also get a positive 8? We sure do. Now we have everything nice and neat connected. Let's go ahead and graph for ourselves. Do our best to make it happen. I'm doing what I can. My drawings sometimes leave a lot to be desired, but that's going to be good enough for us. Let's do another one. Number 10. So this f of x equals x minus 6, x minus 5. So I'm going to do this one faster because I think I showed enough on the last one. You can go back over it one more time. But I'm just going to go ahead and not even write step 1. I'm just going to start writing stuff down. So we got the y-intercept, y-int, y-intercept. I got to plug in 0 up here. So if I plug in 0 into my coordinate, do I really have to show work to multiply -6 times -5? I don't think so. All right, 30. Cool. Also not going to be on our graph, but that's okay. Now, next up, x-intercepts. The x-intercepts also, so at least I'm labeling these, by the way. I'm not like just totally freehanding it. I'm doing some work. The x-intercepts, again, making these equal to 0. Please note, on the test, you got to factor. You just didn't have to on this review packet because you already spent a whole bunch of time factoring the other ones. You got 6, 0 because it's positive 6 there. And 5, 0, again, positive 5 there. For our axis of symmetry. Our axis of symmetry, oh boy, I forgot down here, those are x values. Our axis of symmetry is x equals what's in between 5 and 6. So what's between 5 and 6 is 5.5. And now we got to plug in 5.5. So if you plug in 5.5 into this equation here, well, we're going to have -0.5 left over there and positive 0.5 left over here. And that's going to give us a total of 0.25 negative. So that's an itsy bitsy tiny number. Good luck graphing all of these things. So that's our y value when x is 5.5. There's our vertex. And we just graph as much as we can. So 5.5 is right here. -0.25 is like barely below the axis. And we got a 5 and a 6. And then after that, again, let's use our calculator to get some more accurate coordinates because I don't think we have enough coordinates really to get the whole shape. I mean, look how tiny this thing is. That's not nearly good enough. So let's go back to our y equals screen, clear this bad boy off, type in x minus 6. We got the x. Oh, whoop, forgot the parentheses. X minus 5. Go ahead and graph it up. So again, it looks like it doesn't even show up below the graph. Look how low that is. Double check our work. Trace 5, enter, gives us 0. Trace 6, enter, gives us 0. Plug in 5.5, gives us -0.25. That's perfect. Let's plug in some other numbers that are right nearby. Let's plug in 4. So 4 gives us 2. Let's plug in, how about to the right of it, let's plug in 7. That also gives us 2. Of course it does, because it's to the left of the axis of symmetry. Some more values, let's plug in 8. That's going to give us 6 up here. And therefore, 3 is also going to give us 6. And don't forget our little dotted line going down the middle. That's a perfectly straight vertical line, by the way. And we can connect the dots. Easy peasy. So something that's going to be important a little bit later. Notice how this parabola is a little bit skinnier than that parabola. Maybe you can look at the equations and think about why that is. All right. Number 11. So this time, I'm showing even less work. I mean, I'm getting to the point where I'm done with this video. You know, I want to go eat dinner. I'm hungry. So let's just do it even faster. So we got y. So for our y-intercept, we're plugging in 0 and getting 18. For our x-intercepts, we got 6, 0. We've got 3, 0. For our axis of symmetry, halfway between 3 and 6 is 3 plus 6 is 9, divided by 2 is 4.5. Plug in 4.5 into that guy, that's negative 1.5 times positive 1.5, that is negative 2.25. And we can go ahead and graph this up. So we got 4.5, comma negative 2.25, so that's about right there. We got 6, 0, we got 3, 0, and if we plugged in 2, we'd have negative 4 multiplied by negative 1, so it's going to give us a positive 4 up there, meaning that this guy's up here, and we're graphing it up, straight up and down. Please note, if this is the only work you showed on the test, you better be able to explain to me where you got all these numbers, because, I mean, I'm able to do this in my head, and you could be able to do it in your head too, but you need to be able to explain it to me. Otherwise, I'm going to think maybe you cheated, maybe you looked at your calculator and just did the whole thing on your calculator and didn't do any work for yourself. I need to see that you know the process here. Okay. For the last one, number 12 here, same idea. Y, we got, you know, our first answer, we plug in 0, we're going to get 35. If we have x, we're going to get negative 7, negative 5. We didn't graph any of these y-intercepts, by the way. I'm sorry about that. Man, I should have picked some better numbers for this one. Oh, well. Axis of symmetry. So our axis of symmetry, smack dab in between negative 7 and negative 5, that's going to be negative 6. X equals negative 6. Oh man, I even wrote that wrong. That's our vertex. Our axis of symmetry is x equals negative 6. Jeez. Oh my gosh, over here it's 4.5. I'm getting too tired, guys. Sorry. X equals negative 6 is our axis of symmetry. Our vertex is plugging in negative 6 into the equation. You plug negative 6 in up here, you're going to get 1 multiplied by negative 1. That's negative 1. So we got negative 6, negative 1. And then after that, we got our negative 5 and negative 7. Axis of symmetry going down the middle. And then if we plugged in negative 4, I can teach you a trick here, by the way, if you really like to know. If the change in y here was 1, going up and down, if you move 1 over, the next one's going to be a change of 3. So it's going to go, instead of changing by 1, it's going to change by 3. 1, 2, 3. That's guaranteed to be the coordinate. In addition, that one went up by 3. If I change by 1 again, it's going to go up 5 this time. 1, 2, 3, 4, 5. This is going to work every time. Try it out. Let's plug in 3. Let's see what we get. So, or negative 3, sorry, if we plug in negative 3. Plugging in negative 3 here gives us positive 4. Plug in negative 3 here gives us positive 2. And sure enough, there you go. That's 8. Cool little trick for you if you ever want to be able to do these super duper fast without even thinking about the numbers and just doing a little bit of counting. Please note that won't work on this problem here because there's a 2 in front. It only works on the ones where there's not a number in front. Alrighty, guys. Good luck on this test, whether you have it Thursday, Friday, or Monday. And I will see you guys later. Have a good one.